Welcome to Students Clinic, and today we look at gas laws. You'll find this particular topic in physics and chemistry. And before we go straight into the definitions, we shall look into some of the key aspects when it comes to gas laws. How can you explain all this? A flat tire takes up less space than an inflated tire. How can you explain such an occurrence? Number 2, lungs expand as they fill with air, and exhaling decreases the volume of the lungs. How can you explain that? Also, a balloon filled with helium weighs much less than an identical balloon filled with air. How can you explain these 3 examples amongst so many? That is why it is important that as scientists, as students, we go through the topic of gas laws. This particular topic will help us understand what is happening behind the scenes when we talk about gases. And as part of our introduction, gases are affected by physical conditions. We know very well that there are 3 states of matter. There are solids, liquids, and gases. But we are saying that when it comes to gases, as part of our introduction, gases are affected by physical conditions. When we talk of the physical conditions, we talk of the changes that occur in our environment in terms of certain measurable quantities. For example, there is temperature, and number 2, there is pressure. And when we talk of temperature, the SI unit for temperature is Kelvin, as demonstrated by the capital letter K. And gas laws, all of them, they are laws that relate pressure, volume, and temperature of a gas. Remember, when we are looking at gas laws, we are only looking at gases. Our interest and our focus is on gases. And so, there are 4 gas laws. There is the Boyle's law, there is the Charles law, there is the LUSSAC'S law, and there is also Graham's law of diffusion. But these 3 are the main examples, are the main types of gas laws. And so, when we start looking at the Boyle's law, the definition is key, whereby we shall understand the major aspects of this particular law. It states that the volume, I want you to, if you're writing, you circle this, the volume of a fixed mass of a gas is inversely proportional to the pressure at constant or fixed temperature. There are 3 key words that are important when it comes to Boyle's law. We are comparing the volume of a fixed mass of a gas and the pressure of that given mass of a gas and the temperature. And we are saying that the volume is inversely proportional to the pressure, and temperature, when it comes to Boyle's law, is constant. It is held constant and it is fixed. And in this simple demonstration here, it is a clear example of what normally takes place when we look at Boyle's law. As you can see in our first figure here, we have 2 cans that are filled with gaseous particles, and it is written, pulling up the siphon, pulling up increases the volume and decreases the pressure. When you pull the piston, not siphon, when you pull the piston up, it will increase the volume of the gaseous particles. in this particular place. And pushing down the volume, when you decrease the volume, remember pressure will build up in this particular gas cylinder. Reason being, there will be constant bombardment. Pulling up the volume, increasing the volume will decrease the pressure, because the collision of the gaseous particles in our first diagram will be less. But when you reduce the volume by pushing the piston down, we are saying the pressure will increase. Why? There will be an increase in the rate of bombardment or collision of the particles, which will build up pressure. That is Boyle's law for you. And if we are to draw a graphical representation, it will look like this. On the y-axis, we would have pressure, and on the x-axis, we would have volume. And remember, a curve will be formed there. And in this particular curve, it is very clear that when you increase pressure, the volume will decrease. And when you decrease the pressure, or when you increase the volume, the pressure will decrease. And it is summarized in that way. P1 V1 is equals to P2 V2. Remember, P1 and V1 represent the pressure and the volume of a particular gas, and P2 V2 represents the pressure and volume of another gas. And remember, when we are handling Boyle's law, temperature as one of the physical conditions is constant. Also, this is just for emphasis. With increase, when you're looking at Boyle's law, with increase in volume, there is decrease in pressure. With increase in pressure, there is decrease in volume. Summarized like that. P1 V1 is equals to P2 V2. Number 2, Charles' law. It states that Charles' law, first of all, is the second law that you are looking at under this topic of gas laws, and it states that the volume of a fixed mass of a gas is directly proportional to the absolute, that one is very important, absolute temperature at constant or fixed pressure. When it comes to Charles' law, we are comparing the volume of a fixed mass of a gas and temperature. When it came to Boyle's law, we were comparing volume and pressure. Charles' law, we are now comparing volume and temperature. But how are we comparing them? When we are comparing volume and temperature, when we are handling Charles' law, we are saying that they are directly proportional. What do we mean by that? We mean that when the volume of that fixed mass of a gas increases, the temperature, not just any temperature, the absolute temperature will also increase. And there is a catch here. There is a condition here. The pressure is held constant. And therefore, it states that the volume of a fixed mass of a gas is directly proportional to the absolute temperature at constant or fixed pressure. And then when we look at this graphical representation, we can be able to see clearly that there is a thermometer here which is measuring temperature as T1, and there is one flame here. And remember, the bluish particles, they are the fixed mass of a given gas. And we are saying that when you lower or decrease or push the piston down, the volume will decrease. But remember, at this particular temperature, if the volume decreases, the temperature also of these given particles will decrease. But when you increase the temperature, the volume of this fixed mass of a gas will also increase. And remember, the condition is that pressure is constant. When you increase the temperature, the volume will also increase. When you increase the temperature, the volume will increase. But when you decrease the volume, the temperature will also decrease. When you decrease the volume, the temperature will also decrease. The volume and temperature in Charles' law are directly proportional. When one increases, the other one increases. When one decreases, the other one decreases. And we have this simple illustration of a graph whereby on the y-axis we have volume and on the x-axis we have temperature. And with the increase in volume, there is increase in temperature. With decrease in temperature, there is decrease in volume. And that is what we are talking about. And the particular graph that is going to be demonstrated when we are looking at Charles' law, it shall be a straight curve. A summary as illustrated below, V1 over T1 is equals to V2 over T2, meaning that when the volume increases, the temperature will also increase. When the volume decreases, the temperature will also decrease. The third law is Gay-Lussac's law. Gay-Lussac's law, it states that the pressure of a given mass varies directly with the absolute temperature of the gas when the volume is kept constant. It states that the pressure of a given mass of a gas varies directly with absolute temperature of the gas when the volume is kept constant. When we look at Gay-Lussac's law, we are comparing the pressure of a given mass of a gas and the absolute temperature. And in our case here, we are saying they are directly proportional. Temperature and the absolute temperature. Pressure and the absolute temperature. When the pressure of that given mass of a gas increases, the absolute temperature of that gas increases. When the pressure of that given mass of a gas decreases, the absolute temperature of that given mass decreases. The pressure and absolute temperature vary directly. And we are saying the condition when we are looking at Gay-Lussac's law, students, we are saying the volume will be constant. The volume will be constant. When we were looking at Boyle's law, we were comparing, students, when we were looking at Boyle's law, we said pressure is being compared. Boyle's law, you compare pressure and volume. Charles' law, you compare volume and temperature. But Gay-Lussac's law, you compare pressure and absolute temperature. And the volume is kept constant. And we have this visible representation of what Gay-Lussac's law is all about. And it can be written as P1 over T1, this one represents for a particular gas, is equals to P2 T over T2, this one is for another gas. And we are saying when the volume is constant, this equation is used to compare different conditions on the same substance. But remember, the volume is constant. And we are saying pressure is directly proportional to the absolute temperature, which is measured in Kelvin, meaning that when the pressure increases, the temperature increases. When the pressure decreases, the temperature decreases. Pressure over temperature equals the K constant, and this K constant, we are calling it the proportionality constant. And the graph is like that for Gay-Lussac's law. On the y-axis we have pressure, on the x-axis we have temperature in Kelvin, and when you increase pressure, the temperature will increase, and when you decrease pressure, the temperature will decrease as well. They are directly proportional, and it is a straight line. Also, another demonstration, we say the pressure of a gas increases as its temperature increases, assuming constant mass and volume. Assuming constant mass and volume. What does that mean? It means that if we are going to increase the pressure, the temperature will also increase. Or if we are going to decrease the temperature, the pressure will also decrease. If we increase the temperature, the pressure will also increase. When you increase the pressure, the temperature will decrease. When you increase the temperature, when you increase this one will also increase, as demonstrated here. When you decrease the temperature, the pressure will cool as well, will decrease as well. When you increase the temperature, the pressure will increase. When you increase the temperature, the pressure will increase as well. And we are moving on very well. Graham's law of diffusion. This one is not majorly a gas law, but it is helpful and still deals with diffusion of a gas. And it states that the rate of diffusion of a gas is inversely proportional to the square root of its density at the same or constant or fixed temperature and pressure. And when you're looking at Graham's law of diffusion, we are majorly focusing on the rate. We are majorly focusing on the rate of diffusion of a particular gas as we compare it with density, the square root of its density, or the molar mass. Temperature is inversely proportional. It is inversely proportional. The rate of diffusion of a gas is inversely proportional to the square root of its density. And it can be represented by this summary. T1 over molecular mass of that particular gas is equals to T2 divided by the square root of the molecular gas of that particular gas. So you are comparing two gases, but remember we are saying the masses and the temperature shall be fixed. And practically it has been done in the laboratory through experiments. And if on one side you have hydrogen chloride gas and on the other side you have ammonia gas, we are saying once you release them together at the exact same time, a phenomenon will occur whereby both gases move at the same speed and meet exactly at the middle by reacting to form ammonium chloride. This phenomena, how does it operate? It works under Graham's law of diffusion. Last but not least, we have the combined gas law. And when you're looking at the combined gas law, we are majorly touching on all the gas laws, but using one particular formula. Remember, the Boyle's law has its own formula. The Charles law has its own formula. The Gay-Lussac's law has its own formula. But when we talk about combined gas law, we bring all the gas laws together with their formulas and calculate them as one. The combined gas law combines the three gas laws, that is Boyle's law, Charles' law, and Gay-Lussac's law. It states that the ratio of the product of pressure and volume and absolute temperature over gas is equal to a constant. That is very true. They bring in all the physical conditions and express them in one given formula, which will be equal to a given constant, as demonstrated below. P1 V1 over T1 is equals to P2 V2 over T2. This is what we call the combined gas law, whereby if you were to check Boyle's law, you will find it P1 V1 is equals to P2 V2. And when you check Charles' law, you'll find it there, which is V1 over T1 is equals to V2 over T2. And when you check Gay-Lussac's law, P1 over T1 is equals to P2 over T2, you will still find it there. And in conclusion, this is the summary. This is the summary of what we have looked at in this particular session. The gas laws. You can pause to write this. Otherwise, this one summarizes all the gas laws together with their formulas. Thank you for watching. Ensure you subscribe, like, and share for more content.